In this video we'll look at question 74 from the 2017 exam. So in this question we see a picture of a crane which has a load and a counterweight on it, and this crossbar itself has its own weight which is pushing down, and they give us all the important masses and distances of the respective things which are attached to the crane itself. But the key piece of information here is that the whole system is balanced. There is no motion around this point where the crossbar meets the support. No motion around. Later, the load moves by 5 meters to the left, and the question is where we need to move our counterweight to in order to maintain the balance. So looking back at the diagram, the red mass is going to move to the left by 5 meters, and we can immediately, intuitively see that the counterweight is going to have to move to the other direction in order to maintain the balance and for the bar not to tip over. So the counterweight is definitely moving to the right, but the question is by just by how much. Now when we say balance, we mean the balance of torques. So along the bar we have different forces acting at different distances from the point of contact between the support and the crossbar. That's this black point here. And the torques on the left-hand side have to exactly balance the torque from the right-hand side, the blue torque. Torque is just force times distance, provided the force is perpendicular to the distance, which it is in our case. And when we decide to move one of our weights, like this, by distance delta d, this is going to add a term to the torque on the right-hand side, F times delta d. The same applies for the other side. New contribution F delta d. And in order for this equation to be still balanced, to still hold true, the red and the blue contributions need to be the same. That gives us a new condition we can work with. So we can write the gravitational force as mg, and the g's will cancel. That's just a small improvement. If I now divide by blue m to isolate blue delta d, which we are supposed to find, the distance by which the counterweight has to move, that allows us to plug in the numbers which we are given for the masses and the distance by which the red load moves. That's 5 meters, and we get 1 meter for delta d of the blue counterweight. So the counterweight moves by 1 meter to the right, and that was option B.